Yes, thank you to AI for creating our theme song for this meeting. You too can waste hours of your day by going to suno.com and creating your own music. But thank you all for being here for our April Showers Bring Tableau Powers meeting. I'm having some weird video issues, so I'm going to stay off screen today. But just to give you an idea of our agenda, we're going to do a quick announcement, and then we're all going to get some relationship advice from Andrew Drinkwater. We're going to have a Tableau showcase by Emmanuel Sanchez-Tovar, and then Sam is going to do our office hours today, which is talking about small n filters. And then our next meeting we'll talk more about at the end, but it will be on June 18th. So the big announcement is Tableau conferences next week. So next week, starting on Monday, the Data Fam will be ascending here in San Diego, where Kim and I are. So we're super excited to not be traveling. I hope some of you all are in the area and are going to be at the conference as well. If you are going to be at the conference, we'd love for you to tell us in the chat so that we can meet you at the conference if you all want to meet us. So just to give you all an idea, there's a lot of stuff going on. It's 3 days. It's 200 plus breakout sessions and keynotes and Iron Viz and trainings and meetups and data night out. So there's a ton going on. We did ask last time, and it sounded like most people were not going to be at the conference. So I just want to remind you all, oh, wrong slide. We do have some know before you go information if you wanted to check it out. I did a presentation for the higher ed TUG last week, was know before you go tips. So I'm going to throw these into the chat right now. If you want to watch that recording, or there's also a blog by Sarah Bartlett, who's a Tableau visionary. And she gives some great tips. If this is your first conference, I would definitely check that out. But if you can't make it in person, you also have the option to go virtually. So you can go on Salesforce Plus and get a lot of the content, not all of it, but some of the content will be on Salesforce Plus, recordings of sessions, the keynotes, some of the big stuff will be on there. So make sure you register for that. It is free, and the streaming of that starts on Tuesday. So even though the conference starts Monday, the stream on Salesforce Plus will start on Tuesday. With that, I'm going to turn it over to Kim to introduce our first presenter for today.
Thank you, Miss Lisa. We are so grateful to have both of our presenters here today. And Andrew Drinkwater is our first presenter, who is broadcasting, so to speak, in from Japan, where it is just after 5 in the morning. So we could not be more grateful for his coming today to talk to us about relationships of a Tableau variety. Andrew is the president and co-founder of Plaid Analytics, which helps strategic enrollment management professionals actively plan and better support their diverse learners while meeting institutional goals using the power of data and analytics. Andrew's a co-lead of the Higher Education Tableau user group and has been using Tableau since version 3.0 in 2007. Andrew holds an MBA from Simon Fraser University and has just wrapped up his term as the elected board member of the Canadian Institutional Research and Planning Association. And so with that, I'm going to hand it over to Andrew.
Good morning and good afternoon. Thank you all very much for having me. Yeah, as Kim mentioned, I'm broadcasting live from Japan, so fingers crossed that the internet gods are with me this morning, but I'm very grateful to be here. So today, I'm going to talk about relationships and joins and a few other things in Tableau. So let me just share my screen and we'll get going. Okay, I think you can see all that. So yeah, today we're going to talk about some tips and tricks related to joins and relationships. We'll walk through a couple of demos. I've got an agenda coming up. So Kim already gave a pretty good introduction as to who I am, so I'm going to gloss over that, but I'd be more than happy to connect with any of you on LinkedIn or other forums, and look forward to learning more about your work. We'll talk about different ways of combining data in Tableau. So primarily today we'll focus on joins and relationships. I'll touch very briefly upon blends because they come up from time to time. And just like a trip to Costco where you intended to buy, 25 pairs of socks, there's a few other key concepts that are also going to get thrown in today around level of detail expressions and table calculations. We'll talk about the whens and the whys, go through a couple of demos, and then a few gotchas that come up from time to time, and wrap it all up with some rules of thumb that I found from using these relationships since Tableau launched this way of bringing data together in about 2020. So Kim already gave this introduction, so I won't belabor the point too much, other than to say I am an expatriate or turncoat of the higher education system as well. So I worked at the University of British Columbia most recently as a senior planning research analyst responsible for enrollment and tuition forecasting and admissions data warehousing. And I also help organize the higher ed TUG. We're always looking for presenters, so if anybody is curious, feel free to reach out. I'd love to talk to you. Okay, so we talked about that. I'll skip over all that. These are the things that Plaid does. We work in the data integration analytics space. We've recently launched an enrollment forecasting tool, which we're really excited about. So if anybody's curious, come chat with me. And we work in the data governance space as well, because when you have all these systems firing on all cylinders, you will have a data governance challenge if you haven't started thinking about that path. So we help make that easy for people as well. This is what I'm super passionate about, so I wanted to throw this in here. Enrollment planning is more important than ever. So this is a Canadian example where the federal government cut international enrollments by 30% year over year, which could mean a $4 billion budget hole. It's looking a little more promising than that now, but we help people understand the magnitude of the changes over, say, 5 years, like we're looking at here. Okay, so moving on to the Tableau stuff. So there are many different ways of combining data in Tableau, and there's no such thing as a wrong answer. There's often multiple right answers, and we'll talk about some of those today. If you want to follow along, I put this in the chat already, but you can download the slides that I use today, and you can find the workbook on Tableau Public. Any of the data that you see in here is all fictitious, so feel free to use it as you wish. You'll notice that it rhymes with what an institution might look like, but it's not based on an actual institution. It's based on public data and a whole bunch of assumptions we've learned about working in higher ed for 20 years. Yeah, so with that, let's go. So there's 3 primary ways of bringing data together in Tableau. One is, and 2 of these have been around for quite a while. One of them is relatively newer. So the join has been around, as far as I know, since day one. And joining is the way that in a database, you bring different tables together. And so they have common keys to say that table A connects to table B based on these different keys. And I'll talk some more about that coming up. Relationships are relatively newer. So you can think of these almost like a contract between tables, but it's not as rigid as what you might find in a join. So we'll work through some examples with that. A data blend is the 3rd way, and this has been around for a little while, but truthfully, most people always found it a little bit wonky. It has some of the same rigidity in terms of joins, but it's really particular about primary and secondary data sources and making sure that your secondary data source is more aggregate than your primary data source. And so it can be a place where a lot of people get tripped up. We'll talk primarily about the first 2 today. So at a really high level, I've started thinking about the difference between joins and relationships in terms of game shows. So on the left, we have joins, and we have the game show Jeopardy, which I'm sure most of you are familiar with. The idea to Jeopardy is that you pick a particular square, and there is an answer, they call it, and the role of the contestant is to figure out the question. But there's only one question or response that's valid for that particular square. So it's quite structured and quite rigid, and only one answer counts. Conversely, on the right, we have The Price is Right. And in that game show, the idea is to guess the price of an object and be closest to that price without going over it. So in other words, there are many different responses that could be acceptable. I think of relationships more like this because they're flexible and nimble. And as long as they're within the parameters of the contract that you've defined across the different tables, they should work. So in a more tabular way, which could be downloaded to Excel, of course, because we're all familiar with that. When we think of the difference between joins and relationships, we'll start with joins. So they're computed at the row level. And I'll show you kind of an example of that coming up. The input to joins are physical tables, and we don't mean like real tables in the real world, but we mean tables that exist in your database or views that exist in your database. So from Tableau's perspective, those are physical. They're not defined in Tableau in any way. They exist in the database or other data source. The output of a join is a logical table. So if you combine table A and B, you get a result of table C. When you do a join in Tableau, the join type is fixed. So you choose an inner join if you want everything to match across tables. You choose a left join if you want to keep all of the left and only the matches from the right. The right join is the opposite. And the full outer join is essentially the combination of all of those. So keep all the matches and then keep both left and right where there is no match. And the queries are executed against with that join in mind, essentially. When you get into relationships, the level of detail is actually aggregate, but the aggregate is defined on the fly by Tableau based on what you have in your visualization. So the input to it is logical tables. I'll show that in the demo. It'll make more sense when you see it there. The output is essentially a definition for how you can query the tables, but not actually an output table itself. The join type is flexible, so Tableau will choose on the fly, for better or worse, what kind of join is appropriate in the circumstances, and you can override that in different ways if you need to. The other interesting thing about relationships is that only the tables that you actually use are included in the query, so or based on what you have on the view anyways. So if you had table A and B related to each other, you could use only fields from table A, and then Tableau would only query table A in your database if it was a live connection. Or you could have only fields from table B, same story. And then in terms of extracts for the relationship, they're not pre-computed. They're joined at runtime. So what that means effectively is that Tableau will import the entire table A and the entire table B. And then depending on what you're doing on the visualization, it will run the appropriate joins for you based on that visualization. And each worksheet could have a different query that powers it effectively. I won't talk too much about blends here, but just to briefly mention them, that they do still have the odd use case, but I would say in general, they've been supplanted by relationships. So blends are a glorified left join, essentially, with the primary table being more detailed, the secondary table being less detailed. The one thing that they can do that the others don't do quite as well is that the related fields can be variable. So the one use case I still see for blends is if you have, say, two different worksheets and they need to have different blended relationships between the two data sources that you're using. So it could be based on, say, student ID on one worksheet and based on program code on a different worksheet. You can do that with blends in a way that you can't always do it with joins and relationships. So there's still a use case, but there's not many in my view. Okay, so let's get into the conceptual part and then we'll move forward for some examples. So joins bring together two tables and create a third table, as described previously. Sorry, that's a repeat. There's two different kinds of joins. So row level results in a fixed output. And in turn, you would probably need many different data sources to be able to answer different kinds of questions. Aggregating joins gives you more flexibility, theoretically, in that you can have multiple different aggregations of tables and bring them together with joins, and they result in an output table, but they can be more nimble as a consequence. So what Tableau has done with relationships is take this concept of the aggregate join, but make it possible to run it on the fly. So relationships are a flexible way to combine data from different tables. The really interesting key here is that they keep the original level of detail and domain for each table that's imported. So we'll see that in the demos coming up, but it means that you can do things like you can combine a really detailed table of applicants with a much more aggregate table of targets, which is one of the examples I'll show shortly, and be able to do things at that level of detail with each of them without losing the underlying information. So in a traditional aggregate join, you might have to aggregate all your applicants up, the sum of applicants, to compare it with the sum of targets. You don't have to do that with a relationship. You can have your table of applicants in detail. You can compare it with your overall targets in aggregate. So in turn, you can use the same Tableau data source to answer multiple different questions rather than having to have many different data sources. So that's basically the idea, is you can bring together multiple different tables and result in a more dynamic output. It's created on the fly. So here's conceptually our example. So applicants versus targets, you work at strategic enrollment management, you want to bring this data together. The general framework of Tableau relationships looks like this. So we bring together a logical table A on the left and logical table X on the right. We have a relationship, which is our contract between those two tables. Within the logical layer, they could contain one or more physical tables. So on the right, we're containing just a single one. On the left, we're containing 4 different physical tables that are joined together. So here's our applicants versus targets example. So we've got a relationship between the two. And on the right, our targets logical table consists only of the actual intake targets physical table. On the left, we're bringing together applications, and then we're joining that to information about, say, a program lookup table, a term lookup table, and a national status lookup table. We're going to also create an example similar to this one today. So we've got students and programs and terms on the left, and on the right, we've got the courses they enroll in. This is a PeopleSoft related example. I know many institutions are banner institutions, so the same concept would work there, but the table names would be a little bit different. But what we're doing is we're bringing together moderately high level information by program and term and student on the left, and much more detailed information by individual student enrollments in courses on the right. So think of the average student taking 4 courses. On the right, there'd be 4 records. On the left, there'd be 1 because they're in a single program. So now we're going to do some examples. And the 2 that we'll do live are actuals versus targets and students and courses. But the nuance on students and courses that we're going to look at, I apologize, I didn't put that on the slide, is actually what courses did a student take before they transferred programs within an institution, which is the kind of question that we can answer better with relationships and level of detail expressions than we could with joins. I'll also open it up, time permitting, to a discussion around data densification, row level security, and surveys. So let's go. So our first example is the simple one, applicants versus targets. This is kind of a cardinal example of how relationships can be really helpful. And now for our moment of truth for whether my sound will share properly. Somebody let me know if it's a problem. Our first example is applicants versus targets. We're going to start by putting together a data source based on joins. So we'll drag applicants onto canvas and we'll go to open so we get to the physical layer, and then we will add targets. And we can see that Tableau has made some educated guesses about our joins. So it's based on academic program, but we also want to add S-term. And then we can go to our worksheet and we can put together a very basic summary of our targets by term. So we can see here that there's some noticeable gaps. Generally speaking, our professional and graduate programs only admit in the fall terms. And for sake of demonstration, we'll just keep the 0213 term. Now when we add our targets, we can see that the numbers are astronomically large. So 2.8 million in the Bachelor of Arts, which would admittedly solve the enrollment cliff problem. So why is this happening? It's because with a join, we're duplicating that target for every student that's within the group. So for BA students within the 0213 term, we're applying the target for each of them. We could see this relatively well if we put all the students on here. We can see that each one of them has 991 as its target. But in terms of comparing it to the part that matters for an admission funnel, when we compare it to registered, we can see that only some of these students are registered at all, and they only ever count as 1.0. While we're here, we can also make some cleanup so that Tableau doesn't think these are decimal numbers. And so there we have it.
Now, the problem here, of course, is that comparing 889 to 2.8 million means we're going to be way under target. And we're also going to be inaccurate. Depending on your incentives, one may matter more than the other. So we'll leave a note here to say don't do this, use relationships. We're now going to duplicate our data source, and we're going to try the same idea, but with a relationship instead of a join. So here I'll rename this as relationships, and I'm going to remove our existing applicants table. I'm going to double click on applicants, and I'm going to double click on targets. We can see now it's stayed in the logical layer rather than going into the physical layer. And Tableau isn't quite as good at determining what the relationship should be. I'm not sure if this is intentional or if it's something that will improve over time. In any case, we have to define it for the relationship. So now let's go back and build our basic table. So we have our academic program, and we have our term, and we're just going to keep the latest for illustrative purposes. And then we have our target and our registered. It looks like it didn't keep my default formatting, so let's fix that up. And we can see here now that the BA is much closer to its target. So now we can make meaningful comparisons between a target that's very aggregate by program and the sum of registered that is much more detailed by student. So how do we do that? There's a couple different ways. We can right click and we can create a calculated field using syntax. We can also take advantage of Tableau's ad hoc calculations capabilities. So I've dragged target and registered onto the white space in the detail pane here on the marks card. And I'm going to double click on that target one and hit minus and drag registered on. Looks like I might have got one too many sums on there. I duplicated target by mistake, apologies. Okay, so now we have target less registered, and we can put that back onto our measure names. And we can also see that target is above registered, which suggests that I got this backwards. It happens from time to time. So actually we want the BA to be below target. And now if we wanted to, we could turn this into something much more interesting from a visual perspective. We could use that ad hoc calculation to show us, both with the line chart and with the color, which programs are under our target. We could modify this, of course, by removing our target and registered and just making them part of the tooltip. And now we have a basic visualization that allows us to compare our targets and our actuals. So relationships are a much better way to do this. Now you may find yourself wondering why that actually worked. And the answer is that Tableau's relationship functionality allows us to maintain the original level of cardinality in each of the tables that we get. So in this context, the applicants table is by student number, or MPL ID in PeopleSoft language, student career term, and academic career, as well as admit term. Conversely, the targets table is based only on the admit term and the academic program primary. So the targets is much more aggregate than the applicants table. What Tableau is doing in the background here is it's creating a temporary table, or something similar to a temporary table, for each of these. It only really matters for the applicants in this context, but what we're doing effectively is we're keeping the sum of registered grouped by the program and the term. And we're comparing that to the targets table for the sum of the target by the term and the program. You can see here that these are all related. So effectively, Tableau is aggregating our applicants table to support the question that we're asking. Now, it's nimble enough that we can change our question as well. It's not particularly useful in this context to bring MPL ID onto our view, but we could ask a variety of other questions as well. So for example, we can consider something pretty similar. So we're going to duplicate our sheet here. And in this case, we're actually going to remove our comparison entirely. And we're just going to turn this back to a standard admission funnel. So I'm going to remove anything to do with targets, and I'm just going to have applied and registered. And I'll turn that into a visualization so that we can get kind of a sense of what our funnel might look like for each of these programs. This allows us to use the exact same data source, but for multiple different purposes. You'll note here I didn't even use targets at this point, although I could consider adding them as something like a reference line if I wanted to later. But the point I want to make here is that the same data source is able to answer multiple questions. It can even be used in a really granular way if we want. So in that context, we could have something like a list of all of our students and an indicator of whether they're applied or registered, and turn this into a spreadsheet. This could allow our student recruitment or admissions team to follow up with people who haven't registered yet. Our first example is applicants versus targets.
Okay, so that was our first example around applicants versus targets. So a really good use case is basically when you're trying to bring together two tables that are at different levels of detail. Tableau relationships are a great way to solve that problem in a way that joins are not typically. Now, this is sort of a sidebar, so this is talking about another couple of calculation techniques. So most calculations in Tableau allow you to compute your values at either the data source level in detail or the visualization level. Level of details expressions give you some more flexibility, so they can be more granular than what's in the visualization, so somewhere between the data source and the viz, or they can be less granular if you use an exclude. The fixed can be anywhere you define it to be, and sorry for the terrible animation here, but it can move as appropriate between the data source and any level of aggregation you want on top of that. So our next example goes into which courses did a student take before changing majors. And this comes up, the example that I see this come up most often with is an institution's considering making either a new major entirely or potentially converting one that maybe is only maybe only upper levels but doesn't have a first year, converting it into the full major, including the first year. So this kind of analysis can give them some answers on what are our current students doing and should we consider including those courses as part of our new common core when we introduce our own first year.
Our final example brings together the concepts of joins and relationships. What we're going to do here is we're going to look into internal transfers. For this one, I'm going to make a new data source. What I'm going to do first is I'm going to bring together what is effectively program level information. So in this case, I'm going to use the student career term demo. The difference between this and the standard version of the same table in PeopleSoft is I have internal transfers in this fake data. I'm then going to join that to the academic plan table. I'll then bring in the academic program table. Last but not least, the academic plan table. And we can call this program for sake of argument. We're then going to make a relationship. And this relationship is going to go towards our course enrollments. And the course enrollments of PeopleSoft is based on the student enrollment table, the class table, and in our case, we're going to make use of the academic plan table for a subject lookup. This is cheating a little bit. If you worked in a real institution, you'd have a proper subject lookup, but here we are. We can now define the relationship between our two logical tables that combine multiple physical tables together. And as with many other things in PeopleSoft, it's based on a career. And we'll pick the student enrollment table for that just because it's the first that was in our list. The employee ID. And the term code. So now we should have our data, and we'll rename that second logical table as course enrollments. I missed that previously. So the challenge we're trying to uncover here is what courses did a student take prior to their internal transfer? And we've pre-cooked a few calculated fields to help us with this problem. You can see here that we have a calculation for whether the students are program switcher or not. So we use a fixed expression for this, and it's grouped by student ID and academic career. And then we're doing a count distinct of the primary academic program. If there's 2 or more of them, then we count them as a program switcher. We've got a few others here as well that are also level of detail expressions. So we have a student admit term. This figures out what was their minimum enrolled term. And then we have a similar calculation that goes through what was their program in that admit term. We then have another calculation that looks for if the current academic program in whatever term we're looking at is not the same as the one they were admitted to, then display that term. So that's their new admit term to a new program. And then we use similar logic as we saw with calculation number 2. And in this case, it's looking for their primary academic program if the term is equal to their new program admit term. We have a few other calculations in here. We can review them when and if they're needed. To make our life a little bit quicker, we've also created a test student set, which just has a listing of 4 students that we know are program switchers. So we're going to use this to set up a very basic visualization. So we'll keep only those 4 test students for now, and we will set up our visualization. So we can put our term onto columns and our student number or MPO ID onto rows. And then we'll put our academic program primary onto color. This will give us a sense of when things are changing. We can see, for example, our first person changes from green to teal in 0183. We can then add some context so the user knows what this is. So we'll add their admit program and some information about their transfers. So we can see this first student was admitted to Bachelor of Science Health Science, but later moved to regular Bachelor of Science, and that happened in 0183 term. We can see for our test students that all of their changes happened in 0183, but for other students, this will not be the case. So now we're going to take a look at our sample students. We'll now duplicate this sheet, and for our sample students, we're going to try and figure out courses before transfer. We bring on their current program, and then we want to get into our course enrollments data. So this is where it gets fun. Now that we can see what this looks like for our test students, we can duplicate the sheet, and we can try and figure out which courses they took before they transferred. So what we can do first is we can add subject to catalog number onto label. We can see that things get a little bit too cluttered to actually display. And so the way that we can handle that is we can add an index calculation. And we'll turn it into discrete because we really want it to act like a row number. And we'll tell it that we want to compute using advanced. So anything that we want to group by here gets no check, and the things that we want to order by gets a check. So effectively, subject catalog number is the one that we want. Now I can see that the first student in the list took 4 courses in their first term. They took 5 courses in their second. Apparently they took 6 in their 4th term. And then they had a bit of a gap while they moved into a new program, and then they took other courses to follow. But really what we wanted was only to keep the courses that were before the switch. So to that effect, we have a calculated field for it. And we're looking for the term that we're looking at being less than their new program admit term. And so we'll keep only true in that case. And so now we can scroll through and we can see up to when our students transferred. So this is a good way to combine relationships and physical joins in Tableau, making use of the strengths of both of them. This allows us, in particular, to have program level data, which is one row per student per program, effectively, per term, as well as course enrollments, which is one row per student per term per course enrolled. So it's much more detailed. We can have them in the same place because of how relationships work. So this gives us a solid sense of how we can make use of both joins and relationships together to answer really interesting questions like what courses did a student take before they made their internal transfer? There's also a variety of other summary type metrics that we can do in our dashboards. I'm not going to walk through them all live, but they are on my Tableau public profile if you want to have a dig through them.
Okay, so I hope that opened up at least a couple of ideas for you on how you could make use of Tableau's relationship functionality and when joins are helpful. In the interest of time, I'll just go through this part really quickly because I know I'm right at the end of my rope here. So a couple of use cases that come up over and over again for me is using relationships for row level security. I'm still trying to figure out the full concept on this one, truthfully, so I'd be curious about people's experience if you want to share them in the chat, and I'll respond once the next presentation gets going. But I have found that relationships are better and faster for row level security when you use Tableau extracts. And I posit the reason for this is that they're importing the full table on each side, so a security table, an entitlements table as an example, plus your base data that it's relating to. And then the joins are performed as necessary in the extract. And it seems faster than the old method of using an actual join, but I'm still at a bit of a loss for explaining exactly why that is. So if anybody has great experience with that, I'd love to share thoughts with you. The other one that I see a lot is around survey analysis. So if you are a disciple of Steve Wexler, for example, you may know that you often have to pivot your data in Tableau so that it's one row per respondent per question. So it's a tall data source effectively versus most survey data out of the box is wide data. So one row per respondent, but many columns wide for questions. And sorry, with relationships, you can combine these two pieces together. So you can have the tall data that you need for visualization really easily in Tableau, and you can have the wide data related to it. So you can use that for either intra-question analysis or also to pull together the demographic type indicators that maybe question 4 asks people about their ethnicity, and it makes it easier to pull that together. So it can be really helpful to have a both-and approach for surveys. All right, so a couple of gotchas that I do see coming up quite a lot. Missing values is the first one. So you create this visualization, you expect it to show something, and you get either a blank screen or you're missing a whole bunch of values that you know are there. What happens in this case is typically that Tableau has assumed you want an inner join when in fact you wanted a left join. So you can define that in the relationship setup if you want to, but I found the quickest way to deal with it is actually just put the count field from each of your logical tables onto your visualization. The detail shelf works great for this. When you do that, it tells Tableau that, oh, you actually needed all the values from this other table. And so it may change the result that you see and help you understand why some might have vanished. And it's usually because it's assumed it's an inner join when it shouldn't have been. Occasionally you'll get kind of illogical totals too. So you see this example very tiny at the bottom right where everything is 107 except for the last row for white students, which is 110. This often happens when your detail doesn't roll up particularly nicely to your aggregation. So in this context, it means that there was one white students were in every section of the course, and all the other race and ethnicity students were in every section except for one. And so our totals became a little bit weird, and there's registered fields at multiple levels of aggregation. So you just want to be careful if you have, say, if you think of a hierarchy like course and then course section and then course enrollments, and you have those all related together. Each of those might have a registered field. You want to be careful about which one you use so that when you roll up, it rolls up the right thing. Okay, and last couple of slides here, last but not least. So relationships can be a little bit slow if the database could have done the heavy lifting for you. So if a join makes sense, then use that. The best way to improve the performance is to limit the fields that it's pulling in because it's going to do a full table scan otherwise. For joins, they are better when the secondary table is less granular than the primary. So think of lookup tables as a really good example here. Those should always be joins. unless you have a really compelling argument for why they shouldn't. Like maybe there's values in our lookup table that don't exist in our real data, but we want to keep them. The joins are great for when the database can help you do the heavy lifting, eliminate a ton of records from being imported into Tableau so that you're using the database for processing rather than your local machine. And indexes will help joins. They probably won't make a huge difference to relationships because of the way that Tableau imports that data. Okay, so relationships are super helpful because they're versatile, basically, and they can bring together different levels of granularity to answer multiple different kinds of questions. If you're careful, they'll have no missing or duplicated data, but it sometimes happens, so be a little bit cautious. Some rules of thumb to end this. So joins are great when the secondary table is less granular than the primary table. So these work really well. That's the lookup tables example. Relationships are better when the secondary table is greater than or different in granularity. So think of courses as a primary table at a high level and course enrollments as a secondary table at a much greater level of detail. Relationships allow you to bring those together. Joins will mess you up every single time. So rules of thumb, joins are better when the cardinality is 1-to-1 or many-to-1. Relationships are better for many-to-many kind of relationships. In the event that joins and relationships do not work, try blends, but note that they're a little bit tricky to work with. Okay, so that's my presentation in a nutshell. Slides and workbook are publicly available. Feel free to download them, reach out to me with questions. I did want to give a shout out. I haven't checked the attendance list, but I learned a ton about how to use relationships in Tableau effectively working with Rio Hondo College. So if you folks are on the line, thank you for your support and diagnosing interesting challenges together. We're grateful for working with you. With that, thank you all so much. Questions are welcome. And you can find me on LinkedIn. And my son said good morning to all of you.
Oh, well, thank you so much again, Andrew, for your presentation today. Lisa, do we have time for questions if there are any questions?
We always have time for questions, but I do not see any unless people have been holding them in. If you want to come off mute or throw them in the chat, please do so. So before Andrew runs off with his kids around Japan.
Yeah, I think we're good. Again, Andrew, thank you so much. And we have all of your information and contact information if folks have further questions after the session. So again, thank you so much. Go enjoy your day. Hopefully you'll get a nap.
Thank you all. I appreciate it. Hope to see some of you at CARE in the fall. And for everybody going to Tableau conference, have a great time. We'll talk to you all soon. Take care.
Bye-bye. Okay, now it's time to move on to a member of our group who is presenting today. Emmanuel Sanchez-Tovar is one of our members, but is not from one of our local community colleges. He is originally from Costa Rica and is currently working as an analyst programmer for student health at Oregon State University. He works with Tableau, Python, and JavaScript to gather and transform student health data about how the clinic is doing and what we can do to improve the student experience. And he's going to be talking today about how they do disproportionate impact. And so with that, I'm going to hand it over to him.
Thank you, Kimberly. And let me start sharing my screen. Okay, can everyone see my presentation? Yeah, perfect. Thank you everyone for coming and the same for the Tableau showcase. Today I will be talking a little about how we use disproportionate impact and a little more about how to visualize uncertainty. And the agenda for today, a little just like a reminder for those folks who don't know about how to visualize or what is DI and representing or uncertainty in Tableau. Secondly, a little of what we did here at Student Help and what we are going to then demonstrate a demo. And finally, a couple of takeaways. So move on about identifying disproportionate impact that basically is when one outcome that you're measuring has affect one or more groups in a disproportionate way. This can be any metric, could be academic, or could be in this case that we will be showcasing how the student access the clinic. And then in this case, when we talk about uncertainty, we are talking a lot of how we are representing, for example, the margin of errors when we are calculating this disproportionate impact. So basically, a lot of this has to do with how big or small is this effect that we are seeing. One person, and Andrew mentioned it in his presentation, Steve Wexler has many resources about representative uncertainty using Tableau. And one of their nice blogs or nice information that he has is about representing this uncertainty using, are we back? I saw a little message that said that I was gone for a second. Can everyone hear me?
I think you're good. I think you're good.
So in this case, if anyone is interested, I can put the link in the chat about like how to use this for survey data. And moving on, so what we did here at Student Health was to start creating a metric of how the students or the students that are registered are using the clinic, basically how much we are seeing that. And if that metric in this case, in this particular case, the outcome that we were looking is this in some sort of like has been disproportionate compared to the different demographic groups that we have at Oregon State. So in this case, first we took a look to enrollment trends. For example, how many students are being registered for each individual term, and then how is the clinic and the visit utilization, like how many students come and how frequent they come, and just to identify those barriers or different groups that may have various difficulties. And then finally, we aggregate or look at this data by different demographics across the student population. And let's go and take a look to the demo. Can you still see my screen? So let me, yeah, perfect. So in this case, what we have here is just a small dashboard that has one-page summary for each of all the metrics. In this case that we're looking, the data that we are seeing here is fake. I made like a little edits to the data source just to don't show like any real data, but in this case, it's just the real dashboard that we are using. Basically, we have a little context of what is this proportion, what this means, and how that percentage of students, for example, has been looked into that for different terms and different months. And in this case, we're highlighting the last month that we have data, in this case, winter of 2024. And then going into what we have seen from Lisa and other folks is the heat map, for example, of disproportionate impact, and that it will highlight in red or in any specific color when the disproportion has happened, or in gray in this case when there hasn't been disproportionate impact for that demographic. And in our case, what we did was to create like bands that visualize like that margin of error that we were talking about, like how close or how far are that dot from that margin, and how big is that margin too, because that's also part of the questions that maybe many persons can say like, oh, are we doing better? Are we getting into that? So basically the disproportion, as you can see, will not occur if the dot is inside the margin of error or farther to the right. So in those cases, we're looking all the dots that are to the left for the margin of error. And then as you can see, the margin of error is different for each individual group. That is sometimes difficult to understand like why, and basically depends on the size of that subgroup. And as you can see, the wider that margin of error is because the population is smaller. So in cases where folks are overrepresented, you will see like a smaller margin of error in this case of how the students are using the clinic. And then, so to recreate this chart, if you wanted to do it, so we will start, for example, with our two, in this case, variables that we will have term in the columns, and then we will have the demographic variable that we wanted to analyze in the rows. Then we will being able to bring back, 1 second here. We will be able to grab our proportion, our point percentage gap calculation, if you already have one, and bring it back to the row, to the columns for each individual demographic, and then for each individual term that we are looking at. We can change this to a circle just to make sure that we are looking into that correct. And then here, in most of the calculations that I have seen from other dashboards, we only have one margin of error, and that's basically the negative side. So we are measuring against that negative side of the margin of error. So in this case, we will need to have like a secondary, or in this case, like a positive side of that same margin of error for those calculations to be able to add it there. In my case, I compute those using the downside. And then to include this, let me just remove it for a second. So to include the different bands or the reference, you can use like a reference band and then add it to the cells. And then this will bring a menu where you can select like the different margin of errors that you want to visualize. In this case, this one goes in the band from will be the negative side. And then the band 2, it will be the positive side. And in this case, I recommend to remove the tooltips. And then you can just hit OK. And then the final piece will be to include the DI component. So in this case, we can just drag and drop this one into the colors and calculate it using table count. And basically, this is how you can add more format, like remove all the lines and gray lines that you will see. And then just make it look as you want it. For example, if you want to just remove all the columns and reference line that you don't want to see it. So basically, this is how you can visualize all the different components of the DI, and how in this case it will be creating this visualization, and that way you can showcase not only when that happened, but also how far or how big is that impact that you are looking into. Another thing, and then also if you don't like the fields, you can remove them, and you can just have those without the fields. In this case, the way to do that is just basically clicking in the reference bands, clicking in no field, but you will add like a line in this case if you want to have like just like the where that margin of error looks like. Some people may like it, some people don't. That's totally preference depending on who you are presenting to. But those are, let me just remove the 0 line. That way will look a little cleaner. And that way you will be able to also see that margin of error a little better, I will say, just in terms of that if you don't like to see like the band, or if you have any other preference. There are different ways to represent these. Another way that I found and that I personally like is to creating like a reference line. So in this case, the margin of error is just one line that goes from the negative side to the positive side. And in this case, the dot, it will be just that percentage point gap that we're measuring here. And basically, I will not recommend this to measure multiple terms, like many terms, because it will be too cluttered. So for example, it's hard to look at like in this case. So the best case that I have found for this one is, for example, if you want to compare two different terms, like for example, what has changed from winter 2023 to winter 2024. And especially if you want to have like more rows, for example, if you want to see it by college and to see which college has had that impact over or has any change during those those two periods. So that has been one of the main ways that I can find that this visualization has helped to at least find different changes. And not only is easy also to measure, like also can tell you like how far are you from that margin of error compared to other dots, for example. Let's see. And basically for now, those are the main ways or main visualizations that you can have for uncertainty, and including some of the when you are trying to present that margin of error and disproportionate impact to different audiences, depending on who are looking into this. So finally, some key takeaways from this presentation. Oh, let me see. So you can leverage Tableau to get some insights out of who are being disproportionately impacted based on the different outcomes that you want to measure. Secondly, you can communicate more effectively. For example, not only who, but only how much has been that affected, that specific community or that specific population that you're looking into it. And then sometimes it's hard to represent this uncertainty, and these kind of charts can help you to gain some more clarity about what you can do and what you can create out of that. And with that, I would like, if anyone has any more questions or comments, I will be happy to take those.
This is great. I love, this is a cool way to show it. I do have a question though. How do you educate your end users on what each portion of the chart means? Because they tend to be a stumbling block for us.
Yeah. So for example, I had to include like a lot of text in the tooltip. I didn't. So for example, I had a lot of questions like, hey, what is this margin of error? What is, how that percentage compared to the other one? So I had to include a lot of text, for example, into the tooltip, so they can see like, oh, the margin of error goes from this value, and this is the dot value. So basically in the dot include like, oh, this happened because of, this is the reasoning behind all that information. So that has been one of the many approaches that I have taken, and that I have to just include this, like, hey, if you want to see more, hover the mouse into that dot and it will explain more like what you are seeing in the screen right now.
Yeah, tooltips for the win for sure. We put a lot of stuff in there too.
Do we have any other questions? Well, again, thank you so much, Emmanuel. We really appreciate it. And this is a great way to display disproportionate impact. As Lisa said, we have challenges. It's not a very easy, quick topic to kind of wrap your brain around. And so clean displays like this go a long way to help folks understanding that. Okay, I'm just checking the chat to make sure. Again, thank you so much. If we have any other questions that come in, we will send them your way. And thank you for being a part of our group. And anybody else who ever would like to present something that they're proud of and they're working on, please let us know. We always are looking for topics to discuss. And now we're going to hand it over to Sam, who's going to be discussing ways to filter out low n sizes.
Okay, so let me share my screen. Can you all see this okay?
Yes.
Nobody's saying, okay, thank you. All right, so let me move all the Zoom stuff out of the way. So I'm just real quickly gonna go over 2 different methods that I know of and prefer when it comes to either masking small data values or just not showing them at all. So I built this bar chart already, which has some groups with a small number of students. And so our cutoff at San Bernardino Valley is typically 10 or fewer students is when we do not show the actual number. And so really the first step to doing this would be to just create a calculated field. I typically just tend to call it head count. Since I'm doing it two ways, I'm going to call this the masked version. And so really what I want to do is, if the distinct count of student IDs is less than 11, then what I'm going to do is I'm going to display it as -1 instead. If it is not less than 11, then I'm just going to display the actual count. And the reason I make it a negative number is because if I try to put the actual 10 or fewer, the string value here, it's going to give me an error because I'm not allowed to mix string values and integers in my output, right? And I don't want to convert this to a string in case I want to do more things with it later, like calculate percentages, right? So I'm going to make it any negative value. It doesn't matter because my head count's never going to be negative anyway, right? So this case can never happen unless I tell it to happen. And then I'll click OK. And then I'm going to replace that distinct count ID with my masked head count. And so now anywhere where it had, so I think this was 4 before, this was 10, this was 1. Now it's just displaying as -1. And so what I can do to change that is go into the default properties and change the number format and make it a custom number. And then the first value that you put in here represents positive numbers. And then the second value after the first semicolon is where you can type in and format these values as strings. So for any negative value, and I can't zoom in here. Sorry, at least I tried to download that Zoom It thing and it didn't work. But yeah, so any negative value here is going to display as a string that says 10 or fewer instead of the actual negative value. And so I'll click OK. And now it updates the value to 10 or fewer. So it's still -1, but it's showing as 10 or fewer. And so now, but if you notice, it's below the axis. And so to fix this, what I typically do is I'll edit the axis, change it to fixed, and I'll have it at a fixed start at 0, but then I'll make my end automatic so that it updates whenever a user clicks on a filter or anything like that. And then I click OK, and now it's showing above the actual line. One thing I've noticed that is not great about this method, and this is really just a formatting thing, but let's say you want to switch your rows and columns. For some reason, the 10 or fewer disappears. And so the one thing I've found to do with that is to fix this at like -1 or something. And then it'll show on the right-hand side of the axis. But that's again, only if you're having like the dimension on the rows. When I switch it back to columns, it shows above. But that is the first way. And I want to talk about some more downsides with this. So I have a workbook that's already prepared. Oh, hang on, I have the wrong chart here. One downside with this, though, is if you display the total number of students anywhere and you have only one group that's 10 or fewer, then your users are going to be able to do the math to figure out exactly how many people are here, right? And so this is filtered already. And so this is one downside. In terms of FERPA and everything like that, since there's no record attached to this, it's still not like there's no way to identify these students from here. So it doesn't break anything there, but it is still a little not as secure, right? And so one of the resources I have for you at the end is the rules with FERPA and data and all of that stuff. So one thing that you could do to avoid this is, let me go back to the working. Instead of masking the data values, what we can do is we can actually suppress them. Let me duplicate this as well. Oops, that's not what I meant to do. So to suppress them, it's essentially the same formula, except instead of -1, I'm going to put null. because what this lets me do is once I have the nulls in here, I can actually filter those out of my data. And so they're not going to show at all, right? So nobody's going to be able to do the math to figure out how many students are in each group. If I go back to my already filtered example, this is what it would look like, right? So here it is with 10 or fewer students for the students that identify as Asian. But when I suppress the data value, it just doesn't show. And sorry, I was messing around with this before, so I forgot to change the bar charts here. But this is what it would look like. So the suppressed dashboard just does not contain the category at all, and it doesn't change the total because that filter is only applying to this one sheet. With masked, it's displaying 10 or fewer with the total, and so they could do the math. So there's one reason that you would want to use the suppressed instead, but then there's also a downside with this in that if you try to use this to calculate percentages later, because you have filtered out that category, it's going to give you the incorrect percentages. So what I mean by that is this example here. So when we have masked data values with the -1 instead of the null, it's going to show the correct percentage. Whereas over here, it filtered out that group of students, and so the percentage is going to be incorrect while the count will be correct, if that makes sense. So that is the difference between those two. Can you hide your nulls? Oh, that's a good question. I haven't actually thought about that. So instead of filtering out the nulls, can we hide them? Not sure. That's not one of the options here, but maybe you have to hide the actual category itself, which would hide it all the time. But if somebody has a better answer to that question, please let me know, because that would be very helpful for that percentage problem.
Yeah, I was thinking that your categories would show null, but it's actually just what's on your label, so you wouldn't have an option to hide.
Yeah.
But you could create maybe another calculated field that's like returns the race if the count is less than or more than 10, and then use that as your columns and hide nulls, maybe.
So
And
you're
it
saying
wouldn't mess up the percentages.
Instead of doing like if the count then null else return the race.
Yeah,
and then
use that as your header.
Oh, hang on. It's
I think it's
no.
I think it doesn't like that it says null, and you could just put like instead of saying null, but you could put like exclude in quotes or something.
Oh
You
yeah.
could just hide that or something.
Wait, I see. But you're talking about using the actual exclude function.
Oh no. Oh, what is it? Why is it not like this?
I think it's because this is aggregated, whereas this is not. So it's saying it makes aggregate and non-aggregate. Yeah.
You can wrap race in like attribute. Try that.
There we go. Okay, perfect. And then we'll put this. Oh
no. Okay. We can troubleshoot this later.
Never mind. All right, let me just do this right now. Okay. But I think that was about it when it came to the actual like masking and unmasking and then percentages. There was one other thing I wanted to show. Do we have time? Yeah. Because sorry, I'm just kind of clicking around to figure out where I'm at. Go back here. So the way that I typically make my dashboards is we have public facing dashboards and we also have private dashboards on Tableau server that require a login. I don't want to have two different versions of the dashboard for public versus Tableau server. So what I do is I create a parameter that allows me to switch between the public view and the private view. And then I just publish that to the correct place. And so here, what I mean by that is, so I create a parameter using the list value or the list structure, either private or public. and then I click OK. And then what I do is I edit my headcount function to actually use the parameter. So if it is a private dashboard, then all I need to do is display the count. It doesn't matter if it's small or not, because the only people that are going to be viewing that have access to that data already. Otherwise, if it's public, oops, actually, this should be here. Then if it's public, that's when I do the masking of the small data values. Click OK. And so now, oops, oh, what did I just do? Sorry, I clicked the wrong button. Now when I swap between these two, it will change the actual values. And so when it's on public, I publish to Tableau public, and when it's on private, that's when I publish the workbook to server. And this is also helpful even if you're not publishing to server, even if you have only public facing dashboards, this is still helpful if you want to do some quick analysis and get some quick values. And then you can actually see those small data values for yourself, but you don't have to publish them. And that is about it for what I wanted to show you all. Is there any questions about any of what I talked about? Let me see.
Do you have a workbook that we can pass out to everyone?
Yeah, I'm gonna give this one, the one that's already prepared with all the examples and everything, and the comparison, so that you can see what does it look like masked versus suppressed.
Yeah, that public-private parameter is a really good idea, because version control is always a problem.
Yeah, before I was using that, it was getting really high. I mean, I can show you my I think one of them is still kind of like there. I have two certificates, one that's called masked, one that's called not masked, right? And it was getting really just inconvenient and then tedious. And I would notice, oh, I put the wrong version of the public one up, right? Because it's a few, I made changes to the private one and forgot to update the public one, and it was just a nightmare. Yeah.
I think many of us have been there. So thank you for sharing that too.
Any other questions? And then yeah, we'll have the what's it called? I'll put this dashboard in our CCC TUG resources Google Drive, and we will share that out after the meeting as well. But if there are no other questions, oh, and I have some resources that I wanted to share with all of you. Is this the right button? Yeah. Oh, but now I can't share the actual links. Here, let me put these in the chat. And just so some helpful things, like I was saying, there's this data de-identification overview that the Department of Education published, and so it goes through a few more ways. What's it called? It goes through all the different ways that you can de-identify data, right? So there's some other ones like blurring that I don't have a method for, things like that. But yeah, so this was really helpful to go through. And then there was a relevant Tableau community question that has a similar answer to what I just showed you if you want to read through that. And then, okay, so moving on, we have one heck of a meeting for you in June. And that's we have a collaborative meeting with Higher Education Tableau User Group and the CCC Tableau User Group. And the topic of discussion is transfer. So transferring from a community college to a 4-year. And we thought that was a good topic of conversation for a joint presentation. And then we currently have confirmed John Fink and Tatiana Velasco coming from the Community College Resource Center to talk about some of their Tableau dashboards and how they study transfer. And we have some more things planned, but we're still looking for people to present. So if you'd like to present, please fill out this Google Doc or Google survey. I think oops, sorry, I'm trying to copy it and I can't. So if you have anything that you want to present, if you have a dashboard that you would like to show off, or if you even have a question for office hours, right? So what I just did with the demonstration, if there's something that you want us to show, we can put together a presentation or find somebody that has one. So if you have anything that you would like to contribute, please fill out this form. And I see some stuff in the chat. Okay. And then that is it. So here's our contact information. So you can email us, you can contact Kim and Lisa on Twitter as well. And then, yeah, thank you. If you have any other questions, email us, put them in the chat. We have a few, I don't know what time it is. I can't see anymore on my laptop. But I think we have a
We have
few
like
more
10
minutes.
more minutes if anyone has questions or anything they want to chat or vent about or anything you want to talk about. TC Tableau conference.
Lisa, do we want to talk a little bit about
Oh, that's
AB?
right. So we were talking earlier today about AB 1705 and the math calculus debacle. And we were thinking perhaps folks might want to chat about that or talk about how they're validating that data, or if they are, or issues or struggles they might be running into. So if that sounds like something you want to chat about, come off mute and let us know, or anything else Tableau related. Yes. So if you are coming to Tableau conference, Roshni just put in the chat that the higher ed and nonprofit meetup is happening. It's on Wednesday. Roshni, do you remember the time? 12:30? Sorry, I'm putting you on the spot. Wait, let me see. 12. It's at 12 o'clock on Wednesday, May 5th, at the conference. Okay, well, if no one has anything else, that's it. We hope to see you all at Tableau conference next week if you're going to be there. I only saw one person put something in the chat about that. John. If anyone else is coming, please let us know so we can meet you. Well, thanks everyone. Thank you for coming.